the way, just like we have polar regions, right? And they have ice. I mean, we're supposed to have ice in the polar caps. I mean, they are melting, but you know. The polar caps of Mars also vary with the seasons. The area covered by the polar caps can change very rapidly. So if you're going to have a lot of extreme like variations, then the polar caps are also affected and can change throughout the year. So the area covered by the polar caps can change very rapidly, so they must be thin, like a layer of frost. During winter, the temperature is cold enough to freeze carbon dioxide out of the atmosphere. So remember, the Martian atmosphere also has carbon dioxide, just like Venus. Just like us in the past, we also had a ton of carbon dioxide, which we converted to rock by literally doing chemistry with liquid water in the oceans, which converted carbon dioxide to limestone. Thank you, us. But Mars and Venus can't do that because they don't have the liquid oceans that we are abundantly blessed with. Thank you, universe. So what's happening is there's carbon dioxide in the atmosphere of Mars, but that carbon dioxide can actually freeze in the winters of Mars and give you like polar caps that are frozen carbon dioxide, just like we have frozen water in our polar caps, okay? So it's cold enough to freeze carbon dioxide out of the atmosphere in the winter. The Martian polar caps, particularly the southern cap, because remember the southern hemisphere on Mars has more extreme winters because it is farther away from the sun during the winter because of the tilt of the axis of Mars, you know. So in the winter, the Martian polar caps, particularly the southern cap, are large since they're primarily carbon dioxide with which freezes at 150 Kelvin. I want my friends and cats. Some humans are allowed that are my friends. That's it. Okay, so in the winter, the Martian polar caps, particularly the southern cap, are large since they're primarily carbon dioxide, which freezes at 150 Kelvin. So 150 Kelvin, as soon as you get to 150 kelvins, the atmospheric carbon dioxide can freeze and basically contribute to the polar caps of Mars, especially in the southern hemisphere where it's even colder. Okay, because it's farther away from the sun because of the tilt of Mars, which is similar to the tilt of Earth, blah, 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 whatever. In the summer, the carbon dioxide will sublime. That's what carbon dioxide does, just suddenly sublimes, you know? That is, it goes directly from the frozen to the gaseous state, but there is still a residual polar cap. The residual summer polar cap is probably frozen water, which sublimes at T equals around 190 Kelvin. Pretty cold. I hope you like the cold. Bring a jacket to Mars when you go there. At Martian air pressure. So basically with the Martian air pressure, that's also going to play a role in your phase transition and all that, right? The frozen water will sublime at 190 kelvins. And although at present, yes, I think that life did exist on Mars, even if it was microscopic. It's very well possible because there is evidence of liquid water erosion on Mars. Okay, so if anything has liquid water, traces of liquid water erosion, I would, venture to guess that there might have been life there, but I don't know. That's a research topic that JPL, Jet Propulsion Lab. By the way, if you're interested in these types of topics, especially something like the Mars rover, Mars Europa, these are huge topics of research at the Jet Propulsion Lab, which is affiliated with Caltech. So if you want to study there, work there, whatever, then be my guest. Okay, NASA JPL, NASA Jet Propulsion Lab. Okay, I mean, that's just one example where this is studied. I mean, I'm sure it's studied elsewhere as well, but I know that Europa in particular is a big topic there. Okay, so at present, the water on Mars is primarily in its frozen state. So like I was saying earlier in the live that died, is that Mars, the water is frozen on Mars because it's too cold there. You know what I mean?